This one here is about a little adventure we had with a Jeep. And one of the cool things about Jeeps is they've always had this appeal to them that a lot of other vehicles don't have. Now the newer Jeeps that have got these, engines that just are crammed into the engine compartment are so full and so aggravating to work on. The valve cover material is so thin that you're liable to break it when you're pulling a valve cover off of that dowel at the back and have to replace the valve cover and all that. It's almost expedient if you have to put valve covers on one of the new Jeeps with a V6 engine in it that, you just replace the valve cover as soon as you find out it's starting to leak instead of trying to work that one off of there. Anyway, that's another story. But the Bantam Car Company designed the Jeep actually, but the Army quartermasters, whenever they decided that was the design they were going to use, they gave the plans to to Ford and all that. The Bantam Car Company came up with design, and they were built by everybody else. Just like in wartime, all of the firearms and stuff they use in warfare are built with the same design, but you'll see various different manufacturer names on them and all. But there are some of the old timers that even claim that Jeep won World War II, that you couldn't have won World War II without the Jeep. But one way or another, I actually traded my cousin Billy Joe out of an old Jeep he had. His dad was driving a 73 Dodge pickup that had a lot of miles on it, and I happened to have a 318 engine that I had built that was just, had all new parts in it and everything, and I wasn't going to use it because I got rid of the car that I had built it for. I kind of built the engine for a spare. I had a tendency for a while to keep spare engines on hand. Worked out really well for me on my old 74 model truck. I had a spare engine sitting there. When the engine died, I just stuffed it in there one Saturday, the spare engine that I had sitting on a tire. But anyway, I got this Jeep from my cousin. It was a 47 Willis that he had sitting under the barn out there. A real interesting thing. So I traded him that engine for it. Took it to the house, and had a little flathead 4-cylinder in it. Which one I had in there. So I took that Jeep, went to the parts house over, and this has been, it's been in the 80s. But I went over there and I talked to the people at this big parts house in a big town down the road, and they had all of the stuff I needed to rebuild the engine in that Jeep right there on the shelf. And I was totally astonished that they had all the parts. I mean, the gaskets, the rings, everything. Now, the rear main seal was one of those rope things, you remember the little rope rear main seals that when you put it together, it makes the crankshaft so tight you can't hardly turn it, But anyway, I went ahead and pulled the head off that thing, got the pistons out of it. Real odd because the pistons were really little, but the rods were really long. It was an unusual deal. I got it put together, got oil in it, and, I got some good gas in there and all. And I put that thing in some kind of gear, that I could tell was forward gear by rocking it. And because you had the two levers sticking up, one for 2- and 4-wheel drive, and then one for just a regular gear shifter. And I had a tow bar in front of it. I hooked that over my dad's pickup truck, over the trailer bar on his pickup truck, and I pulled that thing because it was spinning over too slowly because of that rope seal and all that. It was a 6-volt system and all this hogwash. And so when I dragged that thing across the pasture with my dad's old 66 Chevrolet pickup truck, it was in 4-wheel drive when it started, and it pushed me all over the place before I could get it to choke down and stop. But after that, it would start with a key, and I drove it, but then it wouldn't idle worth a flip. So I took a carburetor off of a Karmann Ghia Volkswagen, and I built an adapter to put that Karmann Ghia carburetor on that Jeep, and I even put the little oil bath air cleaner over to the side from the original oil bath air cleaner from the Karmann Ghia. I mounted it over there and put it, and it was just a perfect little running vehicle after that. And I had a lot of fun with that thing. My daughter just loved it. But you got really terrible fuel economy, and it was a strain for it to go over about 45 miles an hour. So it wasn't a lot of fun to drive, but it felt like it weighed 1,000 pounds, and it was really hard to turn over. But I eventually sold it. Anyway, so Chris, this guy that I worked with, came to me with this 84 CJ. He said he had washed the engine and it hadn't run right since. That's a picture of Chris's Jeep. Couldn't rev the engine above 2,500 RPM, whether it was loaded or not, without it sputtering and popping. Now, he'd done all he could to dry everything out, but the problem was still there. And see, all he did was wash the engine. That's the interesting thing about that. Okay, so we got into this thing a little bit, started it up when he brought it, raised it up to 2,500. Had an aftermarket tachometer on it. When the engine started misfiring, the tach started bouncing towards zero, and then back up to 2,500. Now the rule on that typically is, on one of these old kind, if the tach is bouncing downward, it generally indicates a primary ignition fault. An upward bouncing tach points to secondary ignition fault as high as secondary resistance concerns. And so that's just that was an old rule of thumb. You know, back on those Ford Escorts that we used to have a long time ago when I was working on those, and some of them were under warranty, a lot of them were still nearly new in the dealership. The tach would bounce poo, 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 like that. And you know, a lot of the times whenever you've got one that's doing that, you got a spark plug gap too close. But on those Escorts, I found out to start with, I could put a distributor on them, and they would clear up for a while, but they typically came back. I finally figured out that the reason those Escorts were doing that was because the timing belt was getting loose. The distributor's driven by the camshaft, and there was some kind of little, you know, business going on there that was interrupting the primary ignition. But tightening the timing belt fixed every doggone one of those that I ever worked on. Well, the problem almost sounded like a rev limiter strategy on a fuel-injected vehicle, but it wasn't quite so rhythmic. It just sputtering and popping when you hit 2,500. I kept reminding myself the problem had manifested itself after the engine compartment was doused with water. He never had this problem before he washed it with the pressure washer, you know, at the car wash. All right. Now, with these tightening emission standards nipping at their heels in the early 80s, American Motors pieced together a feedback fuel system for the Jeep 4.2-liter platform that included a microprocessor control unit and an oxygen sensor. And then this carburetor here has this little thing here. You notice it's a stepper motor that's vaguely similar to the stepper motors that were used for idle speed control and stuff on some of your Fords back in the day. But this one was longer and had more of a, you know, more length to it. And if you look down in that carburetor when you was working on one of those, you could see that little metering rod going in and out down there. It had a little step to it. And there was a hole back there at the back. You could see it would float in and flow out. And it was responding to the oxygen sensor. And you were basically metering the air. You know, some of your Ford carburetors metered air instead of fuel in order to keep the oxygen sensor happy. That was a strange thing they did. This one was kind of like that. And I would know when I had the thing adjusted right when I was working on these, when I was looking down in the carburetor, and I could adjust it. And if I got it to where that thing was in the middle and it was moving back and forth, I would know I had everything balanced out just like it was supposed to. All right, so you can see this isn't really all that complicated. There's not very many vacuum lines here and stuff, is there really? You know, any of you guys that are old enough to have worked on anything older than about a 1988 model that had a carburetor on it, you know, some of these vacuum schematics look like a road map of Clarksburg, West Virginia. They were really complex. And so this one here, I used to have to redo all of these vacuum lines, or one would come in with all of this stuff stripped off of it. I would put it back on there because I was the one that did that kind of thing. Now this is like wiring anything else up. If you can interpret these symbols here and you can find these components and you follow the vacuum line, you can say, well, this one here hooks up here, for example. And I would just put up, you know, one vacuum line at a time. Now when you get through, it looks like you're the smartest person in the world, but it's like a wiring situation, one wire at a time. Then when you get all this wiring done, it makes it look like you're some sort of a genius because it looks like spaghetti. And of course I used to like to put those together and make them in a little loom, you know, I'd tape them up and all that kind of stuff. I really enjoyed doing that kind of work. And here's the wiring schematic on this same system. And this is how that thing, there's your microprocessor control unit. And I'm not going to go through all of this, but you know, they actually showed you the pinouts on the relays and stuff. This is from the actual shop manual on one of those. Now I made it white on black so that it would show up better on my screen and wouldn't, you know, if I got a white screen behind me, my face gets in shadow and all that. Alright, now the engine was outfitted with this Carter carburetor with that special stepper motor I was talking about earlier. There's your pins on that. That's a familiar looking thing if you've done any work on the old Ford variable Venturi carburetors. They had a vaguely similar plug to that, but the little unit they had was shorter. Alright, it doesn't meter the fuel, it meters the air. The computer controlled ignition timing, the way it was handled, was different from anything I'd ever seen before. But teaching auto mechanics and trying to do a good job is a lot different from fixing cars. I tried to bug a 91 S10 one time. I said, we're going to get some water in the distributor on this thing so these students would see what that's like. And I sprayed water all, this was back in 2001, I sprayed water all up in that distributor with a spray bottle, and I put that distributor cap back on, and I fired that thing up. It ran like a brand new truck. Now what happens when you get it in there and the distributor's hot, it sort of has a tendency to try to evaporate out, and it gets little water droplets on the inside of the distributor cap. I heard all my life growing up that you could take a pencil and mark inside a distributor and it would make it misfire and do all kinds of stuff. And I used to mark around in there with a pencil with all this graphite, because I know graphite's kind of conductive. I never could get a vehicle to run bad like that. It just beats all I've ever seen. I couldn't even break a dadgum car when I was trying to start teaching kids how to fix them. One time I had this Oldsmobile, 97 Oldsmobile with 3.8, bent the gap on every spark plug all the way shut. Screwed it back in, things started and ran. I think I mentioned that one time before. Anyway, so the guy had assigned to the Jeep removed the distributor cap just to make sure there was no condensation hanging around in there, because the guy had washed it. See, that's what started it all. The cap was dry, and before connecting the scope, he snatched the plugs out. They were in fair shape, but the plugs were cheap, so he screwed in a new set of plugs just because. The sputtering and popping didn't change. It was time to move to the next level. This is what we had when we went in here. The RPM was increased. It went from having a normal pattern to losing every other cylinder. That was really weird. Why would washing a vehicle cause this problem? I mean, there wasn't moisture in the connectors. I did know at one time this guy had worked on a Ford Ranger, and he pushed it outside with the engine out of it, the hood off of it, and it rained on it for a couple of days. And when he pushed it back in and put the motor back in, it didn't run worth a flip because all the connectors full of water. So I had to go back there and help him figure that out. We blew all the water out of all the connectors, sprayed some WD-40 up in them, and it took care of that bad running problem. Anyway, the Jeep uses that old 153624 spark pattern common to straight six engines. But above 2500 we were getting into 1 blank, 3 blank, 2, that's where I'm going with that. Clamping the inductive light of a pickup of a timing light around the plug wire leading to each of the 6 cylinders, we moved from front to rear and found that cylinders 4, 5, and 6 were going dark above 2500 RPM. We hit 2500 RPM, this normal looking pattern went away, and we got this. And it didn't run worth a flip. This was an anomaly I either hadn't seen before or had forgotten about. So what would cause that, especially related to him washing it? Well, it had the MCU as a part of the ignition system, and we didn't have any spare parts to use for an ABA swap. Alright, so the MCU is kind of hard to come by. It's an old microprocessor control unit. It looked like an old 60-pin Ford module, but it had different, guts though. Now the DuraSpark with an MCU, this was the DuraSpark setup the normal way. A resistor wire here feeding the coil, and then you've got your distributor here, and it's got this is from your pickup coil, and this is a ground, and then you got your coil that's firing. This is being fired by the ignition coil. Alright, now watch what Jeep did. They put this in between the distributor and the ignition module, which was really wacky. This was so the MCU could control the ignition timing, is what it was. And it was a DuraSpark module. Heck, as I remember, it was even a blue grommet module like we used to use on the old Fords. Well, the engine RPM should be raised to 1600 RPM when you're setting the ignition timing, and the sticker specs under the hood call for 9 degrees plus or minus 2. Alright, so we adjusted the ignition timing. On a lot of these, there was these 2 little vacuum switches back at the back of that valve cover. You had to unplug those, and then you had to hold it at 1600 before you set the timer, or it wouldn't be right. Alright, now I've seen misadjusted ignition timing cause unexpected problems, but I wasn't going to be made a fool of this time. The timing was wrong. We had to retard it several degrees and bring it to spec, but the sputtering and misfiring stayed there. Now whenever I've verified a firm foundation in regard to the integrity of the coil, the wires, the spark plugs, I go to work on the ignition system's primary side to eliminate different components and portions of the circuit. I worked on a 98 Explorer one time, and when that thing hit 4,000 RPM, it would start dropping cylinders real bad and sputtering and popping. That was really a wacky problem because, from the ignition coil to the, and I determined that the primary was actually, getting screwball signals from the engine controller, because the engine controller was firing a coil on that. It didn't have a module. And so I ran overlay wires from those appropriate pins on the engine controller to the coil pack, and nothing changed. And so I got a hold of the field service engineer, and the field service engineer said, let's just put a wire harness on that thing. Well, that's a big job, but I said, I didn't know anything, didn't know what else to do about that, because I'd already thought I'd eliminated everything. The engine controller wasn't causing the problem. The coil pack wasn't bad. The wires had already been eliminated. So I went ahead and put the, I think I had actually done an ABA swap on the engine controller too. But anyway, what I had done was, or I'd put that engine controller on another vehicle and it ran perfect. That's how I figured that out. Long and the short of it was, when I replaced the entire wire harness, it took care of that problem. And I never could explain what was going on there, but that's what you run into sometimes. He tried to come up with some half-baked idea why that would work, but it was just a lucky guess. A lot of the times they tell you to throw a wire harness at it if you don't know what else to do with it, All right, the Explorer anomaly. See how those little wires went straight from here to here? I just replaced those. All right, and so there's where that was. In your coil pack was right here close by. It was easy to do. As far as the Jeep was concerned, we decided to remove the ignition module from its mounting and use jumper wires to connect it directly to the distributor and ignition coil. So that would take the MCU out of the loop. The MCU wouldn't be jacking around with our situation here, so maybe we could figure it out that way. If we bypass the MCU with some alligator clips, because I knew how to wire this thing up, then that would take care of it. Well, the ignition module's got a 2-wire connector with a hot and start circuit, which is a white wire, and a hot and run, which is your red wire. The 4-wire connector is the business end of the module. So the guy that I had working on it removed the ignition module, rewired it like I told him to make it signal directly from to the distributor like an old Ford. That should do something if the microprocessor control unit was the issue. With the jumper wires were connected, we managed to fire it up, and it looked at the pattern, but this pattern was still the same, even going around the MCU, so that way we knew it was not the MCU. So when I had a replacement part sent from the local jobber, we connected it to the jumper wires, and it had a normal pattern, and we mounted it in the original place, plugged it into the harness. We heard a smooth running Jeep and saw all 6 spark lines. So I found that I learned a lot more if I can gather enough hard data to determine as nearly as possible what's going wrong. It's a little more time consuming on the front end, but gaining insight and understanding adds to our mental library and makes us better troubleshooters. I was telling the guy that owned it, his brother had a Jeep just like his, and they would race across these plowed fields on their Jeeps to see who could outrun the other one. And I said, that module is mounted down below the washer reservoir, but you can reach under there and get to it. And I says, if you take this crappy old module and unplug his module from under there and plug this module in, it would really mess him up. It didn't hurt anything, but he would lose half of his cylinders when they were racing across the plowed field. He didn't really have it in him to be that adventurous to sabotage his brother's Jeep. It was probably a bad idea anyway. But that was something that we ran into. It's a lot of fun to get your head wrapped around a situation like that and to tell a story about how you went and found all that. I really appreciate you guys watching, and I hope you got as much out of this, as much fun out of watching this as I had telling it. So I will be talking to you guys next time.